Our big criteria for determining whether something will form a cation or an anion will be based on where you find the element on the periodic table. Yes, there are some fudgy ones near the break between the metals and the nonmetals, but those won't be given to you as monatomic ions. You'll be more likely to see those as compounds, where you can use the other piece of your compound to determine the charge. More on this in Module 2. But for now, we're going to worry about whether something is a metal, which are to the left of our stair step, or a nonmetal, which are to the right. It's okay to simplify it this much because for our purposes, metals will form cations and nonmetals will form anions. Now let's go to work on finding things. Phosphorus is located with the nonmetals, and that means it has to be an anion. Magnesium is located in the main group metals. That means that magnesium will form cations, 2+ cations specifically. Cobalt is located with the transition metals. That means that it will form cations. As a transition metal, cobalt can form more than one type of cation, but all of cobalt's ions are positively charged. Iodine is located with the nonmetals. This means that it will form anions. Aluminum is touching the stair step, but is still to the left of it. So it isn't a metal and it will form cations. Aluminum is another main group cation and carries a characteristic charge of 3+. Potassium is located all the way to the left in group 1. Since it's another main group metal with a characteristic charge of +1, it will form cations. There are 6 items from the problem. They're just grouped by the thing I need to do to answer the question. When you see problems that have the pieces all mixed up like this one, the problem might go faster if you do something similar. Let's work with those near the top first. Here we are moving from the ion to the name. Cations are easier as those ions are named by including the name of the element and the word ion or cation after. Either is equally correct. Anions are slightly trickier because we have to employ those IDE endings that we've learned. So instead of simply nitrogen or the nitrogen anion, N3- is going to be named the nitride anion. Similar story with the chloride here. So for these 3, in the case of magnesium, it would be the magnesium ion or cation, the nitride ion or anion, and the chloride ion or anion. If it was intuitive to grab the periodic table to do these last 3, then good for you. Unless you have it memorized, and don't do that by the way, it's an enormous waste of your time, then you'll need to look up the elements to see where they're located on the table. This will give you their characteristic charges, which will allow you to write their formulas. Lithium is in the first column of the main group. That means that it could either lose 1 electron and become a 1+ cation and have the same number of electrons as neon, or it could gain 7 electrons to become a 7- anion to have the same number of electrons as argon. The latter is darn near impossible and highly unlikely, so 1+ cation it is. This makes the chemical formula for the lithium cation Li+. The 1 is implied and shouldn't be included in the formula. Oxide is the ion formed from oxygen, so that's what we're looking up on the table. You'll notice it's on the nonmetal side and could either gain 2 electrons to have the same number as neon or lose 6 to have the same number as helium. Gaining 2 will be easier for the oxygen, so oxide ions have a 2- charge. The formula for the ion is O2-. While hydrogen can form both a 1+ cation and a 1- anion, I know that I'm talking about the cation here because of the name given. Cations use the name of the element and the word ion, so hydrogen ion must be positively charged. If I didn't know it forms a 1+ cation because I didn't do section M.1 first, then no worries. It's at the top of group 1, which we've already discussed loses 1 electron to form a 1+ cation. You would know if I was asking for the anion hydrogen forms because it would have said hydride ion instead of hydrogen ion. Notice the notation on all 6 of these examples. In all cases, the charge is noted as a superscript to the right of the elemental symbol. If the magnitude of the charge is greater than 1, then the number is written first and the sign is written second.